Tatiana Miles. I'm one of the Makerspace coordinators at the lab in Irvine.
And I'm Jillian Mack. I am the daughter of Anthony Mack, and I am a 3D printing instructor for the makerspace called Vocademy. I also run a 3D printing service called G-Code 3D.
Okay, and this is the introductory video to using the Lulzbot Mini 3D printer.
The software that you're going to be using for the machine is called Kira. Lulzbot has its own version of Kira, so all of the settings are already implemented for this particular machine. There are going to be some tweaks that you're going to want to do. This model here is something that you can get from a variety of locations. You can create your own using different 3D modeling softwares, or thingiverse.com is a huge hub where you can find a lot of free STL files. Once you have an STL file, all you have to do is load model and go to the directory, find your STL file, and it will load up in the center of your build volume. Now, when I scroll out here, you're going to notice I have this green shape here. That is your build area. That is the limitations that you have for this particular printer. That being said, you do want to kind of avoid the edges. I would recommend not going any farther than these exterior squares here. That way there's some room for error on the build plate itself. The larger your prints are, the more room there is for failures as well. Now, navigating through here, you can rotate around your item. I'm holding down the right mouse button, and I can pan or orbit around my model. Using the middle mouse button, you can scroll in and out. This is important because eventually you might have to add additional settings such as support materials in order to make prints successful. On the left-hand side here is all of your different setting options. There's quite a few options, but we're going to focus in on the basics. The first tab here, Basics, which we got to by clicking on Expert, and we are in full settings. The very first one here is layer height. Now, the printer is capable of switching between a very thin layer height and a thicker layer height. The thicker it is, the quicker the print job is, but the more obvious it is that each of those layers are going to be standing out. The thinner the layer is, it's going to take a lot more time. There's also a little bit more room for error, but if it's something really, really small that you want a lot of high details with, that would be recommended. Now, the average is going to be about 0.2, 0.25. Shell thickness is the exterior of your print job. So that would be, if I go into a different mode here, I'm up in the right-hand corner, normal, going down to layers. This view here allows me to see the inside of my print job. So on the right-hand side here, I'm going to scroll down a little bit so you can see what shell thickness is. So this right here is our shell thickness. It's the exterior of the print job, or the mesh. The reason there's two different colors is because of how thick our shell thickness currently is. If we had this thinner, the nozzle size on the machine is 0.5. If you ever forget this, you can go to the Advanced tab and it's listed right there for you. So with a nozzle thickness of 0.5, the absolute thinnest shell thickness you can have is 0.5. So if I change this setting, you'll notice that there is only one line going around my object now. It's recommended that you stay around 2 shell thicknesses, which would equal 1 millimeter. You can make it thicker or thinner, but there is a little bit more room for failure if you do go thinner. So I'm going to change that setting back to 1 millimeter. Retraction should always be enabled. The reason being, every time the hot end moves from one portion of the print to the next, we don't want the filament to be constantly spewing out of the nozzle tip. Retraction releases pressure from the nozzle while it's moving, and then it will reposition itself on a different section of the print job without any of the goo. The next setting we have is bottom and top shell thickness, or layer thickness. So this is how many layers are going to be resting up on top of all of this interior stuff, which we haven't gone over quite yet. I'm going to skip this setting for now, and we're going to go to fill density. This percentage right here is this yellow that you're seeing, infill, and it does come in a grid. This is useful because it acts sort of like an interior support structure. If I change this down lower, you'll see that it's not nearly as dense on the inside. In fact, we only have one line. That's why layer views is really useful. You can kind of see exactly how the interior of your print job is going. And with this one little line, is it actually going to close properly when I get to the top of the print? In this particular situation, I could actually print this thing hollow and it would probably do just fine. But if you were printing something like a box, obviously that would be a lot more of an issue. So I'm going to put this back to 20%. My recommendation would be to hang out somewhere between 20 and 30%. Once you start going into higher numbers than that, let me go ahead and switch this to 50 so you can see. This is getting very excessive. There's basically no reason to ever do this. You can really speed up your print job by printing it hollow or with less fill density, and then you can fill it with something else such as a resin if you need it to be totally solid. So I would never go above 40%, and you're going to hover somewhere between 20 and 30 as your go-to. Let's go back to that setting we skipped. Bottom top thickness. This is how many layers are going to be laying on top of our infill grid. So if we have one thickness on top, for example, 0.25, only one thin layer of filament would reside on top. That obviously will cause issues because you'll end up with these gaping holes on the top of your print. Usually you want to hang out for a lot more. This number is based off of how thick your layer height is. So right now we have 0.8, and if I scroll up, you'll see the yellow become more and more solid, which will make sure that the top of my print doesn't have any gaping holes. I'm going to go ahead and go back to our normal view. So these settings you're not going to need to be changing. They're print speed, temperatures for the bed and the nozzle itself. This is focused on the specific type of material that you're using. Right now, these settings are for ABS material. The next section is important, support type. For some models, there are going to be overhangs, and you need to be able to have support structures generating. Otherwise, this print right here would just kind of sag and fall down. Yes, you can get away with some. 45-degree angles work really, really well. But if you want to play it safe, support structure is always a good idea. We have three different options here. We have none, touching the build plate, and everywhere. Touching build plate means the support structure has to have direct eye contact with the ground. Everywhere, it doesn't matter as long as the angle that we specified, which in this case is going to be 45 degrees. There it is. It will generate anywhere that there is more than a 45-degree angle. So I'm going to change this to everywhere. Notice nothing changed, but if I go back over here to normal and I go down to layers, I can now see where my support structures are generating. In this particular case, we don't need support structures. It is trying to generate a little bit of it there, just underneath the chin. However, this print's relatively small, and that might just cause a little bit more pain than pleasure in this situation. The next setting here, platform adhesion type. These layers that are going around the print but aren't connected are meant for purging. It gets proper flow through the nozzle before starting your actual print job. Over here under platform adhesion type, if I switch to brim, you'll notice that that switches to touching the print itself. This is to try and prevent warping. You can also think of it as like a foot. So if you had something that was really, really tall, it would kind of help grasp onto the build plate a little bit more. Now, if I switch this setting to raft, you're going to notice the cat is actually up a little bit, and there is thickness between the cat and the build plate itself. Give it a minute to finish loading. There it is. So there's that thickness in between the build plate and then the cat. This can be really useful for things that have round surfaces on the bottom. Flat, I would recommend just keeping that off. It's a little bit of a waste of material if you don't need it.
When you click on the model, there's a few additional tools that have become available to you. The first one is to rotate. You can do this by clicking and dragging on each of the circular axes that you see provided for you. Or you can try selecting lay flat, and we'll try and automatically do this for you. Hitting reset will reset the object to the way that it originally was. So if you end up with your kitty way out of whack, don't know how to fix it, you can just hit reset and it will come back in the way it was originally. The next button is scale. There's a couple of different options for doing this. You can work using the millimeters, you can work using the XYZ scaling, or you can also click and drag using this item here. Now notice when I shrink this guy how he's hovering up in the air, but as soon as I let go, he'll automatically reposition himself down to the build platform. Once the object is too large to fit on the build plate, the object will go gray. This is because it's not possible. If this happens to you, feel free to just hit that reset button, or you can scale him down in the different available options to you. Very rarely you might want to use this funny little setting right here. Uniform scale, if you uncheck this, you can adjust the file without having to know any 3D modeling. I'm going to go ahead and put him back to normal and lock this guy. And worst case scenario, I can always hit reset. Now this max button, be very cautious about this. I don't really recommend using it. The reason being, when you hit this, notice how the shadow of the tail is really, really close to the end of the build plate. Keep in mind, that's just the part. What about the skirt? What about the raft? It's a lot safer to do this by hand so that you do not have any overhangs getting anywhere close to the end of the build area. The last button here is mirror, which you can play with if you like. All it does is flip your character around. If you right click on the object, you also have the ability to multiply it. So you can click on multiply, type in the number of copies that you want, and now you have multiple. If something really funny happens, maybe your cat ends up way out there and you can't find it, right click on the item and click center on platform.
Okay, so the Lulzbot Mini is actually a bit finicky. We've had to make some adjustments, so don't follow anything that you've seen online. Follow this video, otherwise you run the risk of breaking the machine, which is never fun to fix. First step is to prep the machine and make sure that it's completely clean before you start anything. Otherwise, the automatic leveling, which I'll discuss in a minute, doesn't work properly, or your print could get messed up, and it's just a whole waste of time. So the materials you'll need to clean the Lulzbot are just some water, acetone, and a few paper towels. You just put a little bit of acetone on the paper towel, not a whole lot. It is flammable, so make sure you don't have anything burning near it. First thing you want to do is, this is called the extruder here. You want to wipe it off with acetone and just clean it really nicely. Be gentle, but you don't have to be too gentle. You want to make sure that any of this plastic that's stuck on here is going to come off properly so that the extruder can properly level the bed. Next thing you want to check is just with water and a paper towel. Look at the bed. It is on glass. There is no PEI sheet. So make sure that there's no leftover glue or residue on the glass. Just take some water and clean it off. Very important when you're cleaning this off, make sure not to get any kind of gunk or glue on these washers. Otherwise the bed won't level properly. So when you're wiping things off, make sure you wipe off the sides and not onto the washers. If you use a scraper to remove any excess gunk off the build plate, make sure that you're gentle with it. The bed is very fragile, can get thrown off easily, so don't push too hard. Take your time, don't rush it. Step one, turn the machine on. Since we decided not to use a PEI sheet with this printer, we're using simple glue stick on the glass to make sure that your model sticks to the print surface. All you do is rub the glue stick onto the glass. You don't need a whole bunch, just make sure it covers the area that your model is going to print on, and that's it. File, print will bring up this nice little window. This controls the hardware on the machine. You'll notice that you can move the extruder around by pressing the arrow keys. You can extrude or retract filament, which we'll discuss when we work on changing filament. You can move the extruder up or down, theoretically. There you go. And then the most important thing is this home button in the bottom left here. We'll move everything back where it needs to be to start your print.
So to change the filament, first we go through the process of heating up the machine so that the filament melts. Then you pull it out and place the new one in. So to do that, you first go to the print menu on Cura. You set the temperature to the melting point of the filament that you're using. For ABS, it's going to be 245 degrees Celsius. This top degrees is going to be for the extruder, which is the one that we want to heat up. When the machine is heating up, you may notice some of the filament starts oozing out of the extruder. Don't worry, this is totally normal. Just take some tweezers and pull it off. Now that the machine is heated up, you need to release the filament. You pull back this little cage here, so it opens up, this guy pops out, and you just pull the filament out. When you choose what filament you'd like, it's the end here, and you use some cutters to cut the filament at a 45-degree angle. The end goes toward the printer. And then, if you look inside the extruder, there's going to be a hole that you push this all the way into, which I can't really see. Push it down until it gets stuck. Reseal the top. And then on the screen, push extrude to get your color to change, and make sure that your new color starts coming through after a few times. There comes the orange. And when it's completely your color, you're done.
So you don't need to preheat the Lulzbot at all. All the temperatures are already set up by the settings. So all you need to do is push print. The Lulzbot takes a while to heat up, but before your print starts, it will go through an auto leveling process. During that, the extruder will lower down and check each of the 4 washers. Very important at this step, you have to watch this very closely because our printer is known to not level properly, which causes the extruder to scrape against the glass, or if there is a PEI sheet, for the PEI sheet to burn. A PEI sheet is a sticky sheet that goes on top of the glass. Once again, we don't have it on right now. It just helps the models that you print stick so that the corners don't fold up, but we've decided to use glass and glue instead to avoid having to replace it. So the printer is first going to adjust itself and clean the extruder, which you should have already done. This is more of a safety mechanism. Now it's going to level the bed. It should just barely touch the washer. If it touches the washer for more than a split second and starts to push the bed down, you need to cancel the print immediately. Once again, very important. Watch and make sure it does not push down too hard. It looks like it leveled successfully. If it did not level successfully, make sure you push cancel as soon as possible. The machine will start to cool down. It will cancel the print. Clean off the extruder and try again. Okay, so the print has just started. You want to make sure you watch the first few layers go down to see if anything goes wrong. If you walk away, something really bad could happen, the machine could break, so just stay around and take your time.
The most common issue with 3D printing will be losing adhesion to the bed. So it's very important that you do not forget to use the glue stick. Even with the glue stick, things can go wrong. If the auto leveling wasn't correct, then the print could fail. When you're watching for the first layer, you want to make sure that the thickness of the plastic on the build plate remains the same and equal around the entire print job. If you're noticing that one of the corners is a little funky, maybe it looks like the filament's swirly and stringy, or maybe it's so close to the glass that it is crushing it, then stop your print job. At that point, there has been something that has gone wrong with the auto leveling. The larger the print job, the more likely you're going to have warping issues. Depending on what type of plastic you're using can also affect this, as well as settings.
There's two material types that will be available to you immediately, ABS and PLA. ABS is the most popular material because it's very easy to sand, prime, paint. It's also got a lot of strength to it. As an example of something I've been working on lately for Halloween, this is my crown for Zelda as a costume, and it is primed. I use a coating called XTC 3D, sandpapered and then coated with gold leaf. The second material that you have available to you is PLA. This is an eco-friendly material because it's plant-based, mostly cornstarch. It also smells really nice and sweet. Some people hate the way ABS smells, and so they choose the PLA because of that. Now, there is pros and cons to both of them. As mentioned before, ABS has a lot of strength to it. However, ABS also has a tendency to shrink after it cools off. So if you're trying to assemble two parts together, there's probably going to be a little bit more sanding to be done if it's on a file that you made and you didn't accommodate for the tolerance between the two pieces. PLA doesn't have as much shrinkage as ABS does, so it is better for these types of prints. ABS is a little bit more matte looking, PLA is a little bit more shiny, so it's a more appealing immediately off the build plate. The durability of PLA is limited since it is an eco-friendly material, so you can't use it for anything that you would like to put outdoors or can get weathered on in any way. ABS will more than likely be your go-to material unless you start printing really, really large or you need things to assemble without you being the maker of the 3D model itself. PLA also doesn't warp nearly as much as ABS does, so if you're having issues with your print job, that might be the material for you.
So this is a quick example of a print gone wrong. As you can see, the model has uprooted itself from the bed, and this will cause the extruder to clog. All right, can you extrude just to make sure this isn't clogged here?
Sure.
You should see some filament coming out of the extruder if it's not clogged. So if the extruder is completely clogged, make sure you contact the lab coordinators and we will come fix the 3D printer.
Notice how in the skirt of this print, there is a little bit of a chunk of material. That's throwaway material, so we're not worried about it. And another good thing about it is it's not on our original print. So the anomaly is not something that we have to worry about interacting with the print job and possibly causing the nozzle tip to clog.
Okay, so in this example, our print has failed. As you can see, part of our little key fell over and the nozzle started extruding in all sorts of weird spaces that didn't have anything underneath it and eventually became clogged. That's the end of the video. If you have any questions or concerns or something happens during your print and you don't know how to fix it, please contact the Makerspace coordinators at Irvine on the bottom of the screen, and hope you enjoyed.